Hello, Challenge 2016. This is my third interactive video. The second one you gave me a 0 for some reason. I do not know why, but I'm good. This is the third one, number 33, since my number ends with an odd number. And it says, a balloon is rising vertically above a level straight road at a constant rate of 1 feet per second. Just when the balloon is above 65 feet above the ground, a bicycle moving at a constant rate of 17 feet per second passes under it. How fast is the distance st between the bicycle and the balloon increasing at 3 seconds later? So, as we know, here's the picture. So here's the balloon. And at when 0 seconds passes, it's directly, this bicycle right here is directly underneath the balloon. However, after 3 seconds, it's right here. So and we're trying to find the rate of change of the distance between the balloon and the bike. So it is x squared plus y squared equals s squared. And that will give you the actual length of this, which will actually help us find the derivative of this, so we can find the instantaneous rate of change. So when we take the derivative of all these terms in terms of t, we get 2x times x delta t plus 2y times y delta t equals 2s times s delta t. And since we're trying to find s delta t, we just divide each side by 2s, and we find out that each term has a 2, so we can cross those 2 out, and we get x times x delta t plus y times y delta t over s equals s delta t. And that's what we're trying to find. So now we just have to find x, we have to find y, but we know delta x because for delta x, and we're using that for the bicycle, that is moving at a rate of 17 feet per second. So we know that x delta t is 17, and we know that y delta t is 1 because this, like we did with that rate, the rate of the balloon moving is also 1. So now we have to find x and y, because now we're 3 seconds later. Because there's a constant rate, the rate doesn't change. However, the distance that they have traveled has changed. So if we go over here, we see that for x, it's originally at 0, but after 3 seconds with the rate of 17 feet per second, it has a final position at 51 feet. And so it's 51 feet for x. And then y, it's originally at 65 feet in the air. And then you add, there's 3 more seconds and 1 foot per second. So you have 68 feet equals y. And to find s at that point, since we also have to try to find s, we do x squared plus y squared equals s squared. And so we use these 2 points. I put it in the wrong order, but basically 51 squared plus 68 squared is 7,225, and that equals, the square root of that equals 85. So now we have that s equals 85, y delta t equals 1, x delta t equals 17, y equals 68, and x equals 51. So now that we have this equation, we can plug these numbers in. So where x was 51, x delta t was 17, plus 68, y was 68, y delta t was 1, and that was over the side length, which was 85, and that equals delta t. And so we get 867 plus 68 over 85. Then we get 935 over 85 equals s delta t. And finally, we get the result of 11 feet per second equals s delta t. So when after 3 seconds of this passing at a rate of 17 feet per second, and this going up at a rate of 3 feet per second, after 3 seconds, the rate of change is 11 feet per second at how these are changing between each other. And that would be it. as you see, I explained it very well this time. Hope I get an actual grade this time. Well, thank you so much, and goodbye.